Every generation believes it has reached the pinnacle of progress, and then something new arrives, something that rewrites the rules of everyday life. Today, transportation stands on the edge of one of those transformative moments where the technologies long imagined in science fiction begin to take shape in the real world. The signs are already here. Cities worldwide are choking under traffic. Commutes that once took minutes now stretch into hours. Trains overflow. Highways gridlock. And still, populations continue to rise. The old systems are reaching their breaking point. But humanity doesn't simply accept limits. It engineers its way past them. That search for better, faster, cleaner travel has ignited a new era in mobility. An era defined by two ideas that once seemed impossible. The first is personal flying vehicles that can lift off vertically and glide above the chaos. The second is hyperloop systems that travel faster than any train ever built. One represents travel in the sky. The other, travel through near-frictionless tubes. Together, they offer a vision of a world where distance becomes less relevant, where borders between regions blur, where the daily commute is transformed from a crawl into a glide or a sprint. These are the technologies reshaping the future of transportation. Technologies once dismissed as fantasy, now quietly turning into reality. The question is no longer if they will arrive, but when. Flying cars have captured the imagination for more than a century. From early cartoons to classic sci-fi films, the idea of lifting off from a driveway has always symbolized the future. Today, that idea is much closer than expected. Engineers no longer use the term flying car. They call them AAVs, autonomous aerial vehicles, or eVTOLs, electric vertical takeoff and landing aircraft. These machines don't look like cars with wings. They look like drones scaled up to human size, sleek bodies, multiple rotors, quiet electric motors, and software designed to keep them stable in unpredictable conditions. Companies like Joby Aviation are already testing full-scale models. Xpeng Aero HT in China has demonstrated a flying prototype that can switch between driving and vertical lift. Aleph Aeronautics has received FAA approval for limited flight testing of a vehicle that genuinely resembles a car. Other companies, including Lilium, Supernal, and Volocopter, are developing air taxi networks as early as the mid-2030s. So how do they work? eVTOLs use multiple electric rotors to lift straight up, hover, and transition into forward flight. They're quieter than helicopters. They're safer due to redundancy. If one rotor fails, the others compensate, and they're cleaner, powered by electric energy rather than fossil fuels. But the biggest engineering challenge is energy storage. Batteries today still struggle with high energy density. An eVTOL needs enough power to lift weight vertically, but also sustain long-distance flight. That balance is delicate. Engineers are exploring lighter materials, improved lithium batteries, and next-generation systems like solid-state technology. Another obstacle is regulation. Air traffic control wasn't designed for thousands of small aircraft navigating between buildings. New digital systems, likely powered by AI, will be required to coordinate flights safely. Noise concerns also remain. Even quiet rotors generate sound when multiplied across a city. And the public must trust the idea of autonomous aerial vehicles overhead. Before flying cars become everyday transport, they must demonstrate the same reliability expected from commercial aircraft. But progress is accelerating. Early adoption will begin with emergency medical response, then remote cargo transport, then air taxis for short city hops. Personal ownership will come later, but it is firmly on the horizon. As battery technology improves and autonomous flight becomes standard, flying cars will shift from novelty to necessity. The third dimension of travel, vertical mobility, will become part of everyday life. A world where people rise above traffic rather than waiting inside it. If flying cars redefine short and mid-distance travel, Hyperloops aim for something far bigger. They promise to collapse the distance between cities. The Hyperloop concept is simple in theory. Remove almost all the air from a tube. Place a capsule inside. Levitate that capsule using magnetic forces. With almost no air resistance and almost no friction, the capsule can accelerate to astonishing speeds. In principle, over 700 miles per hour. That's faster than the top commercial jets of today, faster than high-speed trains by a wide margin. And this isn't speculation, the physics checks out. Several companies are attempting to build working systems. Virgin Hyperloop successfully tested a small-scale passenger pod in 2020. Hyperloop TT is developing full-size tubes and magnetic systems. Transpod announced its FluxJet concept, blending Hyperloop principles with next-generation maglev. But the challenge isn't the science, it's the engineering. Maintaining a near vacuum inside hundreds of kilometers of tube is difficult and energy-intensive. Infrastructure costs are enormous, far beyond standard rail. Tubes must be reinforced, elevated, and perfectly aligned over long distances. Land acquisition alone can stall entire projects. Emergency exits must be engineered into sealed systems. Capsules must be safe in case of pressure changes or power loss. Temperature fluctuations can warp structures, requiring complex expansion joints. But innovation continues. Studies suggest renewable energy could power whole corridors. Solar panels integrated along tube surfaces could offset operational demands. Vacuum sections could be isolated to minimize system-wide failures. Cities worldwide are beginning to explore feasibility studies. In Canada, Transpod is studying a corridor between Edmonton and Calgary. In Europe, consortia are mapping potential links between major capitals. If built, the Hyperloop would fundamentally change continental travel. A journey that currently takes 3 hours by train could take less than 30 minutes. Regional flights would decline dramatically, and countries would become more interconnected, physically and economically. The biggest question is not technological possibility, but political and financial will. If governments commit, the 2040s could see the first commercially operating Hyperloops. Technology doesn't exist in isolation. It reshapes society in ways people often struggle to imagine at first. Flying cars and Hyperloops could transform the design of cities. Traffic congestion might ease as vertical travel becomes common. Commutes that once required hours may shrink to minutes. People might live farther from city centers while remaining connected. Rural areas could experience a revival as accessibility improves. Businesses could expand across wider regions. Hyperloops could effectively create super regions, clusters of cities operating like a single economic unit. Environmentally, the effects could be significant. Electric flying vehicles reduce emissions compared to helicopters and short-haul flights. Hyperloops powered by renewable energy could become one of the cleanest long-distance transport options. But there are trade-offs. Manufacturing the batteries, motors, and steel needed for these systems has an environmental cost. Land use changes may disrupt ecosystems. Energy demands must remain sustainable as systems scale. Then come the ethical questions. At first, flying cars will serve wealthier passengers or specialized industries. Hyperloops may connect major economic centers long before underserved regions. There is a risk of widening inequality. But historically, groundbreaking technologies begin exclusive, then become universal. Cars, phones, computers, and commercial aviation followed the same pattern. Over time, costs decrease, access expands, and technology becomes invisible, simply part of life. There's also the cultural shift. People must trust autonomous systems to fly them safely. Governments must adapt regulations. Societies must redefine what distance means in a world where faraway places feel local. These technologies won't just change how people travel. They'll change where people work, where they live, how cities expand, how economies connect, and how humans experience the planet. It's important to acknowledge the challenges clearly. Flying cars must achieve long-range safety certifications. Battery density must dramatically improve. Noise must be minimized. Air traffic management must be reinvented. For Hyperloops, infrastructure remains the biggest barrier. Costs must fall. Emergency systems must become foolproof. Governments must commit to decades-long funding. No country has approved a full-scale system yet, but momentum continues. Investment in eVTOL companies is rising. Prototypes are flying more frequently. Hyperloop testing sites are expanding. Universities are refining magnetic levitation systems. Digital air traffic networks are being developed. Public interest is growing. And crucially, the engineering breakthroughs needed are measurable, not magical. Humanity has solved more complex problems than electric air taxis. Humanity has engineered more extreme environments than vacuum-sealed transit tubes. The road ahead is steep, but not impossible. Within the next 2 decades, the first major shift in everyday travel is likely. Flying taxis may begin operating in select cities. Limited Hyperloop routes may connect early adopters, and new ideas will emerge from these foundations. Transportation has always been the engine of human progress, and progress never stops. Picture a morning in the 2040s. Instead of starting a car engine, a small electric aircraft lifts into the air. Instead of a train platform, a Hyperloop capsule glides silently into a station. Instead of frustration, there is time reclaimed from the gridlock of the past. Cities breathe more easily, regions connect more tightly, and the world feels smaller, faster, and more accessible. Flying cars and Hyperloops may seem extraordinary today, but so did railways before the 1840s. So did commercial aviation in the 1920s. So did mobile phones in the 1980s. Every revolutionary technology begins as an outlandish idea, until it quietly becomes normal. That is the story now unfolding. A future where humans travel not just along roads, but above them, around them, and beyond them. A future powered by engineering, imagination, and necessity, and a future that is closer than many people currently realize. Thank you for watching, and remember, knowledge doesn't stop at 60 seconds.
Thanks for watching. This is 60-second knowledge now extended, because curiosity doesn't stop at 60 seconds. Subscribe on YouTube and follow us on TikTok.